Welcome to Code Report. I'm your host, Connor Hoekstra. One note off the top of the episode. I posted in my 2-day late last Sunday weekly episode that I was going to try and release a video in the next few days. I didn't get to that, and I'm probably not going to be able to post a video in the next week until the next Sunday weekly episode, which will probably be posted on Monday, not the Sunday. And that's because I'm in the middle of moving down to the United States. So I apologize for the irregularity of the frequency of which I'm uploading. Hopefully it will get back to normal in 1 or 2 or 3 weeks time. But just for the next couple weeks, I'm going to be focusing on trying to pack my things up and move down. So I'll let you guys know when I'm all settled and you can expect regular uploads. That being said, let's take a look at the contest that happened last week. So we had 5 contests that happened, starting off with Code Forces round 498 on Monday. We had the last round in the round 3B before round 4, which is taking place in the upcoming week from the Top Coder website, and that's in the TCO 18 tournament. On Friday, we had the start of the July Circuits contest from Hacker Earth. On Saturday, we had the weekly Leak Code contest number 94, and just a couple hours ago on Sunday we had from Code Chef the July cook-off. Taking a look at our top 10 leaderboards, congratulations to the top 50 that placed in the TCO 18 round 3B contest. At the top of that list, we had in first Ericto, second Igor, in third BQI 343, in fourth Swissstock, and in fifth Marcin_SMU. We had in first place in our Leak Code 94 contest C Xiang, and in our Division 1 Code Chef July Cook-Off, we had in first place Gennady, aka Tourist, in second Igor K, in third F Souza, in fourth Stone Fiang, and in fifth LHIC. And also rounding off the top 10, we had Yui. In today's video, we are going to be covering the solution to the problem entitled OR matrix from the Code Chef July 2018 cook-off. The problem states you are given a matrix of integers A with n rows numbered 1 through n and m columns numbered 1 through m. Each element of this matrix is either 0 or 1. A move consists of the following steps. Choose 2 different rows, R1 and R2, or 2 different columns, C1 and C2, and apply the bitwise OR operation with the second row/column on the first row/column. And the formal definition of this is stated below. For each element of the matrix, compute the minimum number of moves required to make it equal to 1 or determine that it is impossible. Note that these answers are independent, and that means that we are starting from the initial matrix for each of the elements. And note that the constraints for this problem are going to be that we are given t test cases, and that number will be between 1 and 100. N and m, the number of rows and columns of our matrix, will be between 1 and 1,000. And for all test cases, we know that n times n times t basically is going to be less than 10 to the 6. So before we take a look at the example that Code Chef provided us with, this is just a quick overview of what the bitwise OR operation is. If you go to Wikipedia, they have this pretty clear diagram, and it shows you that given 2 bits, a bit being a 0 or a 1, it's going to return a 0 or 1, or you can think of it as true or false in the following cases. So when the bits are opposite, so not the same, it returns true, and if they're the same, it returns false. So let's take a look at the example that Code Chef provided us with. So this is the input and output. So the first number here, 1, that's T, our test case, just saying we get 1 test case, and then we have N and M, the number of rows and columns, and then this is our input. So you can see that we have only 2 of our elements set to 1, and the question is asking what's the minimum number of operations, that being applying a bitwise OR of 2 rows or 2 columns to get all of the elements to be 1. And it says that the solution or the output is going to be the following grid of numbers for each element. So let's take a look at this sort of more visually, and this is our input here and this is our output. And this is going to be a pretty straightforward problem if we just look at what we need to do for each value by comparing the input and the output. So the easiest thing to recognize is that if we already have in our input grid a 1, it corresponds to being a 0 in our output grid. And this obviously makes sense because we don't need to do anything to change 1 to 1. It's already 1. So that takes care of our 1s in our beginning matrix. The second thing we can note is that we want to change 0s to 1s. And we can do this in a single operation if we have either 1 in the column or in the row. So for every element, we just need to check, is there another 1 either in the column that we're currently in or in the row that we're currently in. And if we look at this, we're going to end up with the following. So that's because we have 1 in the first row and a 1 in the third row, and then we have a 1 in the second column and a 1 in the third column. So basically every other element that's not already 1 in your beginning matrix, we can turn to 1 with a single operation. And that just leaves one other case, which is when you're left with an element that doesn't have any 1s in its column or row. And we know that this is going to only take 2 operations because all we need to do is change any other element in a row or column to 1, and then we can do the same operation a second time to get that element to be 1. So these are sort of your 3 cases: if it's already a 1, if there are other 1s in the row or column, and if there's no other 1s in the row or column. And so for the last case, we just are going to check, or it's going to be our else case. And so that's your whole algorithm. There's only one tiny caveat, and that's a corner case where you won't be able to convert elements to a 1, and that is when you have a grid that is entirely 0. So as long as you have 1 0 in your matrix, you're going to be able to turn the rest of your matrix to 1, because you can just apply it first to all the elements in the row and all the elements in the column, and then from there you're going to have at least 1 element in every row or column. But if you have entirely 0s, you won't be able to do that, and so for that case you want to output -1 for each of your elements. So that's the only corner case you have to think of, and as long as you're able to figure that out, you will have a correct solution. So let's take a look at the code for this problem. So here's our code solution. At the top here, we're reading in T the number of our test cases. Then we just have a while loop for our T test cases. And for each test case, we read in NMM. That's going to be the number of rows and columns. And we have here VS and VI, and then also in the solution, a couple macros for I and for J. So these are something that I typically use in coding contests. And I wanted to make a quicker video today, so I didn't swap these out. So just note that that's what these are. And so we have a vector of strings, and this is going to be the input that we read in because there are no spaces in between our elements in the input. We have to store these as strings. And then we are going to declare 2 vector of integers, rows and columns. And this is going to keep track of the number of 1s in our rows and the number of 1s in our columns. And so once we've done this, we're just going to loop through our number of rows, read the string in, store that into our input vector of strings V. And then for each of the characters in our row, we're going to loop over and check, is the current element equal to 1? If so, do an increment on our ith row and our jth column. And so this will give us a quick way to efficiently check, is there any other 1s in our row or column? So once we finish this, we have our information that we need to complete our algorithm. So the only other thing we need to do is just check that is there no 1s in our matrix. So you can do that by using the all of function with a simple generic macro or generic lambda, checking whether they're all 0s. And so with this, then we enter a nested for loop for each element in our n rows and m columns. If we have all 0s, we want to output -1 for every single element. Else, if we know that we at least have 1 1, if the element in our input matrix is a 1, then we want to output 0. Else, if it's not 1 and it's a 0, and we know that there's at least one other 1 in the current row or the current column, we want to output 1. And in the else case, we know that it's going to take 2. And so we just need to break after each one of the rows so that we format our output correctly. And that is the full solution. So the last thing to talk about is the time complexity, and that is going to be quadratic or linear in n times m. Taking a look at the contest happening next week, throughout the week we have the Hacker Earth July Circuits contest continuing. On Thursday we have from Codeforces round 499. On Saturday we have a busy day starting off with the CodeChef lunchtime contest. Then at noon we have from Topcoder the TCO 18 round 4, where the top 100 competitors that have made it through the first 3 rounds are going to be competing for one of the spots in the final 14. And then of course we are going to finish the week off with our weekly LeetCode contest number 95.
As always, if you enjoyed this video and found it helpful, hit that like button. If you want to see more, make sure to hit that subscribe button. You can follow me on Twitter for reminders 30 minutes before contests start, and you can find all of the code shown in my videos on my GitHub page. Thanks for watching, and I'll see you in the next video.